roughly there are two categories of examples. The first category is when we take some pre-trained model and do some operations with that. Usually we use this model for pre-labeling purposes. And the second category is when we actually perform model training. So let's start with inference. And the first example here will be to automatically generate masks for the purpose of pre-labeling. So here is our framework here, and actually we will just need two apps to accomplish our task here. So let's first take a look at the images. We have the images like those, and then we will use serving app to deploy the model. So MM detection framework allows to work with instance segmentation models and object detection model. We will use instance segmentation model in this example. We can pick architecture and the model and the concrete model, the concrete checkpoint, and actually just click serve button. And after that, the selected model is deployed, and then we can run another app from inference apps category to actually communicate with this model and take predictions. So I will connect to the deployed model first. I will pick the classes, define some inference parameters. I may see here the preview of the predictions, actually, the preview of predictions. And I will specify the target project and click apply model to input data button. Once I do that, I will get my images pre-labeled. The next example is very similar but for videos. So the task here is to automatically track objects with rectangles for the purpose of pre-labeling. And again, let's start with the data. So and for this case we will need also two apps, and you will see that the pattern is very similar. So the idea here is to simplify the processes as much as possible. So let's run video. Let's see how our video looks like. And we want this video to be labeled in automatic way. So in labeling interface, the video looks like this. And to initiate this pre-labeling procedure, again, everything is the same. We just run in serving app. This time we will pick object detection task, architecture, the checkpoint, the model, and click serve button. After that, our detection model is deployed. And we can run a bit different inference interface. This time it will be apply neural network to video project. And again, everything is the same here. We connect to the model first, we pick the classes, we can see the preview how the model works and play with, say, confidence level if we want. Then we apply settings and apply neural network, this deployed model to video project. And after we do that, if we open the project in video labeling interface, we will see this kind of results. And it's important to say that this previous app actually solves two tasks. It solves detection task and also checking task. And you see here that the identities of the cars are actually preserved. We can take one more step here and run another app that will allow us to take the ID of the video and actually render this prediction so that we can clearly see how the model works. It's useful for demonstration purposes and for understanding how good the model is. So we run this app, put the identifier of the video, and as a result we will get this kind of video after generated. Let's play it. So what we see here is that model works in a pretty good way. Let's move forward to the LiDAR data. And the idea here is pretty similar, and the task is pretty similar. So we want to automatically track objects with cuboids for the purpose of pre-labeling. And the pattern of usage of Supervisely will be also similar. So we will just need two apps, one serving app and one app from inference interface category. And our data looks like this. So this is just Kitty data set. And first we run serving app to deploy the model. Again, the same procedure, pick the architecture, pick the model, and click serve button. and the model, after that step, the model is deployed. And now we run inference app called apply_NaN to point cloud, connect to the model selected, pick the classes of interest, put some parameters like confidence levels and so on, and finally just pick whether we want to solve detection task or detection tasks and taken simultaneously, and click apply model to input data button. And as a result, we get our point cloud pre-labeled in this kind of way.